In this episode of our series, we'll learn how to allow a player to leave a game session and then pick right back up where they left off. Today we'll dive into the concepts of session management. We'll be creating unique player IDs, managing session data on our server, and using network manager actions to detect when clients leave or disconnect from our game. So without further ado, let's jump into it. In this episode, we'll be digging into the various MLAPI and networking topics that will push us to think outside the box when considering how to manage player disconnections and reconnections in seamless ways. If you're new to this video series, I encourage you to check out the first videos in the series, as we'll be using several different previously covered MLAPI mechanisms to accomplish our task. We will be enabling the ability for a client to enter a game session, leave the game session whenever they desire, and rejoin the session where they left off previously. The server will manage tracking the player's previous game state and will ensure that when the client rejoins the game, that they're able to hop back into the game no problem. To be very honest, this by far will be one of the most complex tasks we will have accomplished together, but by the end of the video, you'll have a good grasp on the principles of session management and what to consider when implementing similar functionalities in your own game. So these are the steps that we'll be following today to accomplish our goal. First, we'll be creating the ability for players to have a unique player ID that will allow them to be identified by the server when they join a game. Secondly, we'll be creating a data structure that will be used to store player-specific session data. Next, we'll be creating a data object that the server will own that will allow us to store our player-specific session data in our game. After that, we'll be using MLAPI's network manager actions to detect player disconnections or when players leave the game. Finally, we'll be creating the logic that allows players to rejoin the game. I know this probably seems like a lot of steps, but don't be intimidated by it. Yes, it will be a decent amount of work to make this all come together, but I'll be guiding you every step of the way and explaining the code and the process. Before we hop into the code, I encourage those who may be following along to download the starter code and starter project from my GitHub page. I've made some updates to the game. In order for you to follow along one for one, you'll really need the latest project and code. So go ahead and check the description below for the links to the starter code. Alright, let's jump into step number 1, or adding the ability to create and set unique player IDs. So the first thing we're going to do is navigate to our project assets folder, navigate to our scripts folder, and open up our script titled Game Manager. With that script open, we're going to go ahead and add a few lines of code within our start method. To save some time, I'm going to copy and paste the majority of the code for today so we can spend time breaking it down and not just writing it on the screen. Now with our code pasted, let's go line by line. In our first line of code, we are creating a new variable that will be setting a player ID value from our player prefs player ID field. If you're not very familiar with player prefs or player preferences, essentially player preferences allow us to locally save certain types of data to our game that we can retrieve at a later time. In our case, we're looking for save data called player ID in our player prefs. If the player ID data exists, we set its string value to our new variable. If it does not exist, player prefs will return an empty string. You may have already guessed it, but this player ID player prefs is where we'll be storing our ID for each of our players in our game. This ID will be unique to each player and will allow us to identify each individual character separately in our game. But when a player first plays a game, they will not have an ID, so our job is to create one for them since it does not exist. In our case, once we detect the user does not have a player ID, player prefs returns an empty string, and we use the C# system library to create a unique identifier for us using the GUID.newGUID method. We convert that GUID type object to a string, and then we set its value into our player prefs and save it so that even if the player closes the game, they will be able to retrieve their player ID on the game restart. And then in our else condition, you'll see that if we already have a player ID, we'll just print it out to our console for debugging purposes. Now that we have the ability to create unique player IDs, we need to create a mechanism where the server is able to know what each player's unique ID is when they join a game session. So let's hop over to our car player script and add some new code to make this happen. Back in our editor, we're going to head into our netcode folder and open the car script file. With our car script file open, we are going to do 3 quick things. First, add a network variable for managing our player ID for players on the network. Second, create a RPC function that will allow us to update that player ID network variable on the server. And then finally, call the RPC method on player network spawn to send that ID over as soon as we join the game. So first, I'm going to paste in this line of code for our variable. We are already familiar with network variables, so all I'm doing is creating our player ID network variable with the type system GUID. The reason I'm using system GUID and not string is because network variables cannot have the type string, and using the GUID type directly is a good alternative for holding our player ID value. Once we have our network variable set up, let's scroll down and paste in our server RPC set player ID method. I'm not going to spend too much time explaining this, but simply we are making an RPC method that will allow us to set our player ID network variable value from a string that is passed into our function. In order to set the value correctly, we will have to utilize the parse method on the system GUID object to convert our string into the GUID type. Finally, we'll scroll back up to the top and paste in some code to allow us to actually call the RPC method on car player's network spawn. We are retrieving our player ID from our player prefs and then calling our set player ID server RPC method if we are the local player. With our player ID creation all set up, let's move on to step number 2, where we'll be creating a data structure that will be used for managing our individual player session data. This struct will be used as a mechanism that will store individual player data when they disconnect from our game. It will act as our uniform structure for player session data. To save us some time, I have already added the player session data struct to our starter package, so let's take a quick look at it. Navigating back to our Unity editor, let's navigate to our script folder, open up our netcode folder, and then open the folder titled Data Objects. In this folder, we will open the file titled Player Session Data. As we can see, this is a very simple data structure. So let's quickly break it down. The first property is simply storing our player's ID in string format. From there, we have a vector3 property called last pause, which we'll use to store the last known position of our player prior to them disconnecting from our current game session. The final line is a quaternion property, which will store the last known rotation of our player when they left the game. And that's it for our player data session structure. So let's move on to step 3, where we'll be creating an object that our server will be using to store and manage all player session data in any particular game session. Let's flip back over to our game manager script and we'll be adding one line of code. This dictionary object will be what the server will use to store data about all the players that join the game. Our key value for our dictionary will be our player's ID, and our value will be our player session data object associated with that player. This object will be updated whenever a player leaves the game and will be referenced when a player joins the game to see if the newly joined player has session data already associated to it on the server. And that's it for our saved player session data object setup. So now let's move on to step 4, detecting when a particular player disconnects from our game. This is extremely important, as in order for us to store the most accurate player data when a player disconnects, we need to grab that data right as the player is leaving the game. Now, in order to accomplish this, we will dabble with Unity's action registering functionality. What I mean is that in order for us to be aware of when a player disconnects from our game server, we must tap into functionality that is baked into the framework that is MLAPI. In our case, we'll be using MLAPI's network manager's OnClientDisconnectCallback action as our means for detecting when a player disconnects from our server. So let's flip back over to our car player script and set this up for use. So the first thing we will be doing is registering to the network manager OnClientDisconnectCallback action in our car player's OnNetworkSpawn method. So let's go ahead and add the code into our OnNetworkSpawn method, and I'll dig into exactly how it works. As a part of our isLocalPlayer conditional, we'll be adding an else statement and then pasting in the key line of code. Essentially what this line of code does is allow our server to monitor when a player disconnects. What we are doing is leveraging our network manager singleton object and listening to when our network manager notifies that our player has disconnected. If you're unfamiliar with this syntax, the plus equals OnClientDisconnectCallback tells our network manager that we'd like to register or listen for when this particular action is fired. When that action is fired, our local OnClientDisconnectCallback method will be called and will take in any parameter that action passes to it. So in order for this to actually work, we need to create an OnClientDisconnectCallback function that will actually be called when our client disconnect action fires. So let's go to the bottom of our script and add in our needed function. With our function pasted in, you'll probably note that one of the parameters it takes in is a ulong named client ID. Whenever the disconnect action is fired by the network manager, it also passes a client ID by default. We will not be using this parameter, but it may be useful to you in the future. So before we move on to our last step for today, we need to unregister from our client disconnect action in order to ensure that once our player object is no longer in our game, our network manager will not attempt to send data to a non-existing object or method. Within our onDestroy method, we'll be adding an else condition to our isLocalPlayer condition where we'll be unregistering from our action. So with our else condition added, we'll paste inside the line of code we need. This line of code is nearly the same as our registering line of code, but we will have replaced the plus equals with a minus equals. As I mentioned before, we need to unregister from this action or it will introduce errors whenever the script is removed when our player character is destroyed when a player disconnects. One thing I have not noted about the registering and unregistering of the OnClientDisconnect action is why it is called when the game object is not the local player and only when it is the server. Well, the simple answer is that at the moment, the only place we want to listen for our disconnect action is on our server so we can store player data when clients disconnect. As you build your own games, you may want to register for disconnects on all player objects regardless if they are the server, local player, or what have you, but in this particular case, it's not needed. In this step, our code will be split between two different scripts, CarPlayer and a script we have not engaged with up to this point called Drive. Just a note about the Drive script, this will be replacing the movement script we initially started with when we began the series. It's a bit more complex movement script and is a mix of my code and code obtained from a Unity asset. The only thing to really note is that just like the movement script from earlier, it is utilizing network variables to track the position and rotation of our car player, and those network variables and RPCs are implemented exactly the same way. With that being said, let's get into the last bit of code. So still remaining in our car player script, let's navigate down to our OnClientDisconnect function. In this function, we'll be adding code that will allow us to save our player session data to our server when our player disconnects. As before, I will be pasting in the code we will need and will explain what is happening line by line. First, we'll be ensuring that this code can only be called on the server. From there, we are creating a temporary player session data object that we'll be using to store our car player session data to be saved to the server. The first thing we store to this new object is the current player's player ID value from our network variable. From there, we store our player's last known position and rotation into our player session data object. Finally, we have a conditional statement that checks our saved player session data object to see if this particular player data already exists inside the object. If it exists, we just access the object using the player's ID as a key and overwrite its current value with our new player session data. If it doesn't exist, we add it as a new entry into our dictionary object by using the add functionality. And just like that, we've saved our player session data to our server. Now it's time to add the logic that allows a player to rejoin the game with their previous session's data. While still within CarPlayer, let's scroll up to our setPlayerID server RPC method we created a bit earlier. Within this method, we're going to paste in some new code. So what this code does is check if when a new player passes its player ID to the server network variable, if it had previously been a part of this current game session, aka if it had disconnected from the game earlier. If a player previously joined, we assign its position and rotation values to the drive scripts corresponding network variables. Using this RPC method ensures that we are applying the correct positional and rotational data to the correct player's game object. So now to finish up our code, we will be jumping into our drive script. Heading back to the editor, we will navigate to our scripts folder under assets and open the folder titled car. In the car folder, go ahead and open the drive script. Once in the script, let's navigate down until we see the on-network spawn and finished loading functions. Currently, when our drive script is spawned onto our network, it invokes the finish loading method after about a second, changing the isLoading flag to false. Right now, this isLoading flag is not being utilized, but in a moment, we will be implementing it. In our update function, directly under the isLocalPlayer conditional ending brackets, let's paste some new code. The reason this chunk of code exists is because previously in our car player set player ID server RPC, we set our position and rotation value from our saved player session data. The reason this matters is that we need some time to load in the saved player session data before we allow the user to take control of the car player. If we do not add this isLoading condition, there's a strong chance that our saved player session data assigned to our network variables will be overwritten by our client when it calls the server RPC position and rotation method on the server. If that last statement didn't make much sense, the best way to understand it is to remove this conditional statement and see how it affects the game. But before we start our test, one quick thing I want to note is that I added a chunk of code in our car player script that allows us to easily exit a gaming session as a client or entirely end a game session as the server. In the car player update function, you will see a line of code that says networkmanager.singleton.shutdown inside of the get key down escape key conditional. As the code suggests, this line of code allows for a clean disconnect from our MLAPI gaming session and ensures that the disconnect action is called on player exit. With all that being said, let's go ahead and build our project and see our session rejoin logic in action. With our game running, let's go ahead and start the host game in our Unity editor. Let's wait a moment and then move our player character around a bit. Now let's move over to our built application and jump into the game as a client. Let's wait a moment and drive around a bit. Let's find a good place to park in view of our host and exit the game by pressing escape. And as you can see, our player has exited the game in the host view and we've been navigated back to our main menu view. Now this is where we get to see if our code really works. Now just like before, let's navigate back to our menu and select client. And just like that, our car player loads in at the location it was at when it was last in the game. As you can see, the implementation from a visual standpoint isn't perfect, but the core functionality is working correctly. Now this is not a perfect implementation of session management in a multiplayer game, but it is a solid look at the mechanics on how it works. What I'd like you to do now is consider how could we make it more efficient, and is there anything that we might have missed in order to make this a more clean implementation? One hint I can give is, what happens when the host ends the game, starts a new game session, and a client from a previous session joins that game? Well, that's it for the code, and we can now all say we know how to implement session management within an MLAPI game. As you may have noticed, session management is an interesting and nuanced topic. We covered an extremely simplified case of how we could implement session management into our game, but there are so many different ways and approaches you can consider for your own games. As some of the more astute viewers may have noticed, this episode wasn't about timing events in MLAPI as I had previewed in our last episode. The reason being is that as I did more research into timing events in MLAPI, I didn't think MLAPI's implementation really deserved its own in-depth video at this point. Instead, I will be taking the feedback that I got from you all and spending my energy in making a general video that covers latency and timing topics in multiplayer games. Now, I can't make a promise on the timeline for that particular video, but know that it's in the works and definitely on the top of my mind. As I mentioned before, I want to make sure I do it right and I don't want to rush it at all. So for our next episode in this series, I'm actually not 100% sure what we'll be covering. I have a few different ideas that I've been kicking around, but I haven't fully decided on what I want to do just yet. At this point, we've essentially touched most of the basics of MLAPI, and now it's time to get into more intermediate level topics. I have been considering implementing a lobbying system into our game as suggested by some of you here on this channel, and I'm even debating diving into netcode scene manager or diving into more advanced implementations of things like network transforms and network rigid bodies. So anything in particular that you all would like to see me cover next? If so, please leave a comment below, as I'd love to hear more suggestions and ideas on what to cover. As always, thank you so much for watching, and I look forward to coding with you all again very soon. Y'all take it easy, and until next time, peace.